Welcome everyone to AeroProbe. Thank you so much for coming here today. I'm really excited to share this day with you. I'm nervous too, so I know most of you know AeroProbe pretty well, and if you do, you know that we have been operating as two divisions, Measurement Solutions and MELD. Our Measurement Solutions division serves unmanned systems, turbomachinery, aerospace, automotive, and wind energy companies around the world. We provide critical air data to operate or improve designs. We help cars go faster, planes fly safer, and engines deliver more power. We've contributed revolutionary technology to the unmanned systems industry with our micro air data system. Our MELD division has similarly interacted with multiple industries while working to develop a brand new technology. For a decade, we've invested in R&D, starting with an idea and working to create it, prove it, and scale it. Our exciting news is that MELD has grown so much it can't be a division anymore. It needs to be its own company. We wanted you to join us for the launch of MELD Manufacturing Corporation, a company that will revolutionize manufacturing. Our mission with MELD Manufacturing Corporation is to revolutionize manufacturing across industries with our innovative technology for additive manufacturing or 3D printing of metals. This patented process is unique and differs from others because there is no melting of the metal. Because it can be scaled to manufacture very large parts, it will open up new possibilities for the use of additive manufacturing at sizes never seen before. This is the future of additive manufacturing at scale. The transition to a dedicated company and equipment sales comes after a decade of R&D efforts, demonstrating success in materials like titanium, steel, nickel-based superalloys, copper, magnesium, and aluminum. I'd like to thank our friends at iAutomation for this video to help explain it.
What makes a MELD process unique is that it's solid state. There is no melting. We stay below the melting temperature, and this is what results in a number of really great characteristics in the build. Not only do we see really great material properties, but our deposits are also fully dense, meaning that the part doesn't require a secondary step, and there's very little waste. It's a very green process.
We are very passionate about the MELD process, and we're very driven to see it kind of take off, proliferate throughout industries. So the machine itself is a very robust machine. It's capable of processing your soft materials like aluminums up to your nickel alloys. It's repeatable. It behaves like we want it to behave. The automation system we put in place performs as you expect it to perform. And it's able to do what you tell it to do, so you can able to program in your geometries you want and come back to the same thing every time you want to do it. When you compare the MELD process to conventional additive manufacturing processes, we're putting down a lot more material, a lot faster. So if you're looking to build very large components quickly without additional processing required, this is a good opportunity for that. So when the customers reach out to us, we're equally as excited to educate them and inform them about the process and technology. Excited to just work with them and figure out how this process can help their needs.
We can repair unweldable materials, join or coat dissimilar materials. So the options that this process creates really opens up new product opportunities. Everyone involved in the manufacture of metal or metallic components has or should have an interest in this process.
So I've asked a few of our colleagues and collaborators to join us today and share their experiences with this exciting new technology. And the first that I'd like to introduce is Sean Fleming, who is Chief Technology Officer of Metalsa. Please help me welcome him.
Thanks, Nancy. I guess before we get started, I'd like to extend a thanks to Nancy and to the Aero Probe, or the currently unveiled MELD team, for inviting us and letting us be the industry representative to showcase this technology, because I think it is pretty exciting and it does address a lot of the concerns and key pain issues that we deal with and our customers deal with. So maybe before I get into the details, I'll just give a little background on who is Metalsa, because that's probably a question, is what do you guys do? So at Metalsa, basically what we are is a tier 1 supplier of automotive structures. So for example, we have 3 different divisions. So our first division is light vehicles. So I think everybody's familiar with like the F-Series truck, Tundra, Tacoma, Ram, Dodge Ram, but now it's just Ram. So we basically build all the light vehicle frames except the Titan, Nissan Titan, and the Silverado. Then when we move into the next area is what we would call our passenger car. In that, we deal with more of the body structure. So it's like the sub-Class A surface. So it's right behind the paint, what you don't see, but is more of a structural component to the passenger car. And then the last area is what we're involved in, is commercial vehicle or heavy truck. So basically in the heavy truck area, you basically have C-channels, 2 C-channels. It's like the backbone of the truck. We provide roughly 50% of the market with so basically like your Volvo Mack, your Kenworth Peterbilt. So that's what we do. We're approximately a $2.5 billion annual sales per year company. So just a little background on who Metalsa is. So maybe if we can go to the next slide. Since, as Nancy mentioned, I'm responsible for the commercial vehicle technology area. So basically what we focus on is lightweighting of structures. So, you might think at first, well, just take weight out, that's lightweighting. But the issue is there's other drivers too, like durability, life, safety, the structural integrity. So there's a lot of other things that we look at that we have to also maintain besides just taking the weight out. So those are a lot of the drivers. Then how do we get there? There's basically 3 things that we look at to get there. The first is advanced materials. What materials are out there? Steel, aluminum, different alloys. The next area is going to be in the area of design and architecture. How do we change or modify it to optimize the performance, taking the weight out? And the last area, which is kind of gets to what we're here for, is the area of advanced manufacturing, or in this case, additive manufacturing. And how does that play a role in what we want to do? So if we can go to the next slide. Okay, on this slide, basically I'm going to kind of compare and contrast kind of where we're at today and where we need to go. So where are we at today? Well, we're basically at 99% of the trucks you see on the road are heat-treated side rails, steel, okay, and they're basically bolted technology, bolted to cross members, somewhere between 5 and 10. And so what does that mean? It's about 50-year-old technology. It's a very over-designed, currently it's an over-designed frame, and it's a very, I guess you could say, not quite optimal. So the question is, but if it ain't broke, why fix it? Well, that's kind of the issue. In the last 10 years, we've gone through several emissions rounds, and basically what that means is for good reasons. It's to clean the air up. But the byproducts of it are, we've added about 1,200 pounds of parasitic weight to that truck. What does that mean? Well, to guys that are getting paid for what's on the truck, a lot. Because the average bulk hauler, the guys that are hauling weight sensitive, $10,000 to $15,000 of sales they lose a year. So that's kind of a big deal. Oh, and then by the way, Department of Energy comes along and says, hey, we like the idea that the air is cleaner, but now we want you to improve the freight efficiency. That's cool. How much would you like? How about 100%? What? Cool. So what does freight efficiency mean? I mean, there's a lot of things that come into play when you talk about freight efficiency. You've got brake thermal efficiency, so that's engines, right? You got rolling resistance, axles and tires. You got light weighting, that's us. AeroPro, that's materials, that's frame, that's chassis. And then there's other things too, but it's basically this huge equation but somehow we got to get to 100% improvement. So this is a large initiative through the Department of Energy. It's about $150 million a year split between 4 different OEMs. We're involved with 2 of them. But on one of the projects that we were working on with one of our partners, Virginia Tech, we've been a partner of theirs for about 10 years now, and we got talking about, more efficient joinery and brackets, and they said, well, have you guys talked to AeroProbe at all? And we're like, who's AeroProbe? And they're like, well, they're a company right here locally. And I'm like, okay, so 3 years later, here we are. So it's exciting because we've actually had several advances in what we've done, and maybe if we go to the next slide, I'll just kind of keep it simple here. But basically, there was three issues that we were dealing with. The first one is effective joinery. Right now, most of the joints are bolted, riveted, welded. They work, but we need to be better because we're trying to take weight out. So if we take weight out, we got to be more efficient. We got to be more. So the ideal is instead of 2 pieces, 1. So ideally, if we can make it behave like 1, so guess what? We got this additive friction stir welding. It's pretty close to 1 now. So that's one objective. We met that. Next objective is, well, we have this thing called corrosion. It's probably the number 1 or number 2 key pain issue in the industry. So what does that mean? Well, if you got 2 pieces, chances are you got an air gap in between those pieces. So what happens? Grit gets in there, moisture gets in there, salt gets in there. If you're in the rust belt, it's number 1 issue probably because it ruins vehicles. So, okay, under normal conditions, that gets in that air gap, and over time, it frets, and it just basically rusts or corrodes. But with this process, that goes away. The air gap is gone. So now we've got, like I said, almost like a single piece. So now that corrosion issue. So that's issue number 2. What's the third one? Well, in addition, like I was mentioning, we try to do more, I guess you could say, efficient manufacturing. Well, one of the things to being efficient manufacturing is consolidating or reducing the number of parts. Well, one of them is, can we clean up the number of parts? Can we reduce fasteners, weldments, whatever, however we're joining pieces and parts? Okay, if we can use this additive process, we can eliminate fasteners, we can eliminate weldments. And the other nice thing about it is, okay, typically if it's a weldment, you're gonna get a heat affected zone. So you're gonna affect the properties. But the way this is done, it stays below that temperature, so you don't modify and have those heat affected or those locations where it modifies the properties of the parent metal. That's another bad thing. So I guess, in closing, what I'd like to say is it's really cool for our area, right? Commercial vehicles. But we also got, like I said, light vehicles and pass car. So the scope is much wider than just commercial vehicles. But it's even more than I think automotive. I mean, because you've got you've got construction, you've got agriculture, you've got aerospace. These guys, some of the same key pain issues we deal with in automotive, same key pain issues that they're going to be in these other sectors we don't work necessarily in, but I can guarantee you in the discussions that I have and stuff with people in the industry, they're dealing with the same things with more efficient joinery, lighter weighting, the issues with how do you make up for that and still get same performance. So on that, I guess I would just like to say that, again, AeroProbe has been a great partner of ours, and I'm glad to be one of their champions to kind of promote this technology because it is good technology. And it is the kind of stuff that, it's ready to go. I mean, you've got people out there that if they know about it, they're going to buy it because it does address some of the key pain issues that we deal with, and so do other industries. So on that note, I guess I'll stop my ranting and rambling and open it up for any questions, and I'll try to answer it. And if I don't have any answers, I'll make something good up. So I don't know if anybody has any questions.
So it looked like there were rough edges. You don't need to machine those down because that square channel is sufficient for your purpose.
I would say depending on how the fit up is, there may be surfaces that need to be machined, but if there's other edges that are not coming into contact as far as the specific joint or the specific application, probably not,
What about ribs on the doors? Adding ribs on the doors for safety?
As opposed to like a weldment?
Sure.
Yeah, I would say those are the types of applications, like I say, it might be outside of commercial vehicles, but in pass car, those are the kind of things that typically are welded. So certainly if you can eliminate welding, and it's a much cleaner joint. there's nothing else, I'll step down and
That was fantastic. Thank you, Sean. And the next person I would like to introduce is Kelly Johnson from Senator Warner's office.
Good afternoon. My name is Kelly Johnson, and I am Senator Warner's regional representative here based in our Roanoke office and for the New River Valley. Senator Warner regrets that he cannot be here today to congratulate you all in person and on this announcement while the Senate is in session voting, but he did write a note that he asked me to share on his behalf. I am pleased to extend my congratulations to AeroProbe Corporation upon the launch of the MELD Manufacturing Corporation. Today, the community gathers to celebrate AirProbe's innovation and dedication to developing unique solutions for your customers. Your commitment to progress has led to the development of this new method for additive manufacturing and the launch of the MELD Manufacturing Corporation. Through continuous dedication to improvement and quality, AeroProbe is thriving and has made significant contributions to the aerospace, automotive, turbo machinery, wind turbine, and wind tunnel testing industries worldwide. We are proud to have your headquarters here in the Commonwealth. I am excited to join you with your friends, customers, family, and community in sending my best wishes for your continued success. Congratulations again. Sincerely, Mark Warner. Thank you.
Thank you, Kelly. The next person I'd like to introduce is the only man here in a bow tie, I believe. Dr. Paul Allison is an assistant professor at the University of Alabama, and I'll ask him to come up and tell you that we are very excited to join Dr. Allison at the University of Alabama next week for our first ever users group workshop.
Thank you. So I'm skipping class today, so I have this is my hour lecture, I believe. So I'll try to be brief. But I first I met Nancy on an airplane. We were very fortunate to sit beside each other, and she started telling me about this transformative technology. And I had just moved from Army ERDIC, the Engineering Research Development Center, to the University of Alabama, and I was amazed at how I could envision this technology changing the research landscape through solid state additive manufacturing, but also for repair, joining, coating, which we did a lot of work on supporting the nation and the warfighter. And we were very excited to get the first B8 machine, the sister to this one, at the University of Alabama. And we now have a program that is examining recycling battlefield scrap for forward operating bases for the Army. And so AeroProbe, or MELD Manufacturing Corporation, is our partner along with the Army Research Lab on that project. And I think this has an opportunity to not only save lives, but also energy and really benefit the way we look at advanced manufacturing in remote locations. So, thank you very much for inviting me here, Nancy.
Well, I have to admit to you guys, since these are my friends and family here, that Paul is very kind, because the truth is, after I accosted him, he was a hostage in the airplane seat next to me, and he was working on his laptop, and I kind of looked over, which is probably inappropriate to admit, but what's this man doing? I see materials work, and I said, I think we must be going to the same conference. And he said, oh, yes, we are. And I said, great, let me spend the rest of the plane ride telling you what we do. And we got off the plane, and for some reason he was walking really fast. I don't know. But I saw him again in the luggage area. So while he was waiting, I guess he wasn't willing to leave the airport without his luggage to escape me, so he had no choice. And I said, I'll just be right back. And I ran and got my suitcase and started pulling metal samples out in the luggage area of the airport to show Paul and his colleague. And we've been friends ever since. Thank you, Paul. So the next person I'm very honored to introduce is Laura Blevins from Senator Kane's office.
And I am Senator Kane's regional director that serves the New River Valley, and instead of Roanoke being my home base, Abingdon is my home base. But like Kelly said, our bosses are busy in Washington, and he did provide me with a letter to read. Dear Nancy, congratulations to you and the AeroProbe team as you celebrate the launch of MELD Manufacturing Corporation. When I visited you in 2013, I was impressed by the AeroProbe team and enjoyed learning more about the company's technology. Over the last 10 years, you have dedicated countless hours of research and development to create an innovative additive manufacturing process for metals that is now ready for commercialization through the new company MELD. I am very excited to see global interest in cutting-edge technologies developed here in Virginia. I understand that this technology will help the world transition to advanced manufacturing and offers the potential for the further adoption of additive manufacturing. I commend you for this tremendous achievement and look forward to future accomplishments from both AeroProbe and MELD. Sincerely, Tim Kane.
This is so fun. So, I saved the best for last. Longtime friend Jack Lesko, Associate Dean for Research and Graduate Studies at Virginia Tech, will close our speaker panel.
Well, thank you, Nancy. And on the way over, I was thinking to myself, boy, this has been a long time. I've known Nancy for quite a while. When our company first started back in 2008 in the Knowledge Works building, Schultz Korean was right down the way. It just so happens that one of my colleagues was the founder of AeroProbe. And so it's been interesting to watch this process take place. But I will say that I'm really proud of Nancy, and I recognize how hard it is to run a company. Our company is still in business, and for some reason it's doing much better since I left. I'm not sure why, but I realize how hard it is to get a product off the ground, and this is truly an accomplishment. To be able to get from some very basic concepts, ideas, grit them out, get them into some sort of form where you can get a sense of that this is going to be something. As I've spoken with other companies that Virginia Tech is a part of in terms of our research relationships, they recognize the advantages that this technology has. And I also see the opportunity here that this technology provides us with other means to produce other microstructures that we wouldn't normally be able to take a look at. And this, I think, generates an opportunity in the scientific community, which I think is amazing. So we now have R2V2, and I guess this is based on Star Wars characters, as I understand it. So we have one of the very early ones, and we're in the process of getting that up and running. And I think part of what makes this, I think, unique and a great opportunity for Virginia Tech is to carry on the relationship that Virginia Tech has through our office, Link. We have a new office. Where's Karen? So Karen back there, Karen Clark, she's a member of Link. This is an organization that was just started by Virginia Tech at the university level as a way of engaging companies. And so we're in the process now of working with AeroProbe and now with MELD Manufacturing to develop a master research agreement and a way in which we're going to work together. And again, I think this is all part of the commitment that Virginia Tech has to working with companies in the region. And we see this as a great opportunity for experiential learning for our students and our faculty, and an opportunity to be able to share ideas and concepts across industry and academia. So we're very proud to be a part of this. I'm very happy to be able to be here and to be given the opportunity to say some things. And again, I'm very proud of AeroPro, the team, and NANCI for all that you've accomplished. Congratulations.
Oh, look, here's a sheet about 10 more speakers. Y'all ready to be done? No one started clapping when I said there were 10 more speakers. So thank you to all of you who were kind enough to come here, make the time, and especially Paul, who got on an airplane to be with us and share this day with us. I wanted to make sure that I shared with you that we'll continue this launch of MELD Manufacturing Corporation at the Rapid Conference in Texas in 2 weeks. So we're very excited to make our debut commercially in that way. And of course, our new website, meldmanufacturing.com, went live today. So I'd like to just say, I think if you visited here before or by the time you leave today, I believe you'll just feel this sense of pride in this company. It's palpable. We are proud. We're proud to lead a revolution. MELD is the future of additive manufacturing. And I want to close by expressing my appreciation for all of the people who helped today be possible. It takes people to breathe life into an idea. It takes people to nurture it and to fight for it. And it takes people to believe in it and take a chance on it, like these folks did. We have a great technology, but without a great team, without great customers, great partners, and great support, we wouldn't be here today. So thank you to all of you. Thank you. So we would like to invite you to stay. We would love to give you a tour of our facility. We'd love to give you some demonstrations of our technologies. We would ask for no photography during this portion of the program, but we will work with you if you would like some photographs or video. So I have 3 of the world's most handsome gentlemen who will step up here. You just know who you are, right, by that title? Rob, Jim, Sam. And you can choose which one you think is most handsome and join them, because these 3 gentlemen are your tour guides. So if you would like to have a tour and see some demos, then please just pick one of them, and they'll begin to lead us around. We have 3 different stops on our tour. Otherwise, we'll be happy to just hang out with you and chat back in the cantina that we passed through. So thank you again. We really appreciate it.